Okay, what we got here is we are once again sticking with conics and we're with the ellipses. And what we're going to do is we're going to figure out what is the eccentricity. Eccentricity. We have two different problems for you. In order to find eccentricity, eccentricity is a ratio. It's a ratio of how much of an oval or how flat the ellipse is going to be. We can determine this by taking a ratio of c, the distance from the vertex, sorry, not the vertex, the center to the foci. Okay, so from the center to the foci, we get our c value. Now, if we divide that by the distance from the center to the vertices, which is a, we get a ratio. That ratio, the larger it is, okay, the larger that ratio is, the closer it is to 1, the flatter the ellipse is going to be. All right, so if this ratio is, all right, closer to 1, all right, to 1, then it's going to be flat. If R is small, okay, close to 0, all right, close to 0, that means it's going to be almost a circle, or it's more circular. Okay, so it's more circular. So we got that. Now, to figure this out, it's pretty simple, actually. First off, you have to identify, looking at your ellipse, or either put it in standard form or find where the standard form is, and find your c and a values. Well, in a standard form of ellipse, we have two values, b squared and a squared. A squared is always the larger of the two values, so we know that right there is a squared. So 100 is a squared, okay? And this would be b squared. Now, since this is a squared, a has to equal 10. So over here, we're just going to put 10 in for a. Now, to find c, we have to use our two values and use this equation. All right, c squared equals a squared minus b squared. So from here, we're going to take our 100 minus b squared, which is 81, and that's going to equal c squared. C squared then is going to equal 19 in this case, I believe. All right, 19. So c that we want, c is going to equal the square root of 19. Oops, sorry about that. We'll just move that up, and so c equals the square root of 19. So we take that square root of 19, and that's our eccentricity. Okay. We can do the same one. I have another example. All right. Doing the same thing. Eccentricity, once again, eccentricity is going to be c over a. What's our a value? Well, there's a squared. Once again, a squared is always going to be the larger of the two numbers. All right, so we have a is going to equal 7. All right. C squared, we can equals a squared minus b squared. And so that is b squared right there. So what we're going to do is we're going to take 49 minus 25 and equals c squared. What we have is 24, and the square root of that equals c. And so, which we can simplify if you want. 2 squared to 6 equals c. So we have, for our final answer, 2 squared to 6, all right, over 7, and that's our eccentricity. Not too hard. Key thing is finding a and c. All right, once again, a is always the distance from center of the ellipse to a vertice. Okay, from the center to the vertice. C, on the other hand, is the distance from, all right, the foci, or one foci, to center. And that's what C. B is the distance from the center to the minor axis, a point on the minor axis. All right, so there you go. Hope that helps you out. If you have any questions, maybe you could share some other tutorials.